Okay, welcome back. Oh, you've been working hard, and by now you really understand mitosis. You know what the special steps are in meiosis. And so we are going to go through the 8 steps of meiosis, and it should all fall into place for you. And if not, remember, there's link for supplemental videos for you. There's a link to help you counting with whether or not things are haploid or diploid and how many chromosomes, how many chromatids are. And then there's tutoring as well as meeting with me for Zoom sessions if you need help. But let's get started with meiosis. So remember, before meiosis, we have interphase. And in interphase is when the chromosomes were duplicated. So before we had a chromosome, which is like one little chromatid. And after duplication, we had 2 sister chromatids attached at the centromere. And the cell was said to be 2N or diploid. All right. Now, because we are a sex cell, we are going to have meiosis instead of mitosis. We need to make gametes. All right. So we're going to enter meiosis. And in meiosis, we're going to start with prophase 1. And in prophase 1, we're going to form the tetrads, where dad's sister chromatids number 1 are going to meet up with mom's sister chromatids number 1. And the same thing for number 2, 3, 4, all the way through. And they are going to be doing the crossing over. And so now we are going to be seeing evidence of the crossing over for the rest of meiosis. So remember, tetrads form in prophase 1, and this is where the crossing over occurs. From there, we're going to move to metaphase 1. Do you remember the special step that occurs in metaphase 1? That's right, independent assortment or random alignment. And for that to happen, the cells had to align in the middle of the cell. The tetrads were aligning, and it was random as to whether or not the sister chromatids from mom or the ones from dad were going to be on one side of the cell or the other. Remember, we had 8.3 million possible combinations that were going to occur. From there, we're going to move to anaphase 1, where the spindles are going to pull apart, only we're not pulling sister chromatids apart. We're going to be separating the tetrads at this point in time. So we are going to have a full chromosome, 2 sister chromosomes for each number going to each side. So all we're doing in meiosis 1, specifically anaphase 1, is separating the tetrads. So in telophase 1, we end up with 2 haploid daughter cells because we do have half the number of chromosomes that we started with at the beginning. Okay. So we started with a diploid cell. And at the end of meiosis 1, we end up with 2 haploid cells because we have telophase with cytokinesis. We end up with 2 daughter cells, each of which are N or haploid. So that's the end of meiosis 1. So now we're going to move to meiosis 2. And each of the cells from the end of meiosis 1 is going to undergo meiosis 2. Oh, and don't forget that each of these cells is still going to show evidence of crossing over. So in meiosis 2, this is why it's showing 2 cells, because each one of these cells is going to be doing each of the 4 steps. So now we have 2 cells doing prophase 2. So in both of these cells, the sister chromatids are still attached. Okay. Notice here We have evidence of some crossing over here, and we have evidence of some crossing over there. In metaphase 2, they're going to line up in the middle, single file. The spindle formation is going to attach to the centromere. And so in anaphase 2, the sister chromatids will separate and will migrate to opposite poles of the cell. And we will end up with 4 haploid daughter cells. So our product at the end, our 4 gametes, are 4 haploid cells. So in meiosis, we start with 1 diploid cell, and at the end, we're going to end up with 4 haploid spermatocytes or 4 haploid oocytes. Okay, so that was it. So make sure you talk yourself through the process. Don't forget, some of these chromosomes are going to show evidence of crossing over. And an equal amount of them are not going to. And because of the random alignment, you could have some cells that don't show any evidence of crossing over and other cells that show a lot of crossing over. It's all random, genetic variability. All right, I will see you soon. And we are going to come back. We're going to talk about the third thing that gives us genetic variability, because we've already done crossing over. We've already done the random alignment, and we have one more thing. And then I will do a final comparison of mitosis with meiosis, just to make sure you've got these complex topics down pat. Thank you. See you shortly.